Hello. In this video, we'll be seeing two-dimensional arrays. So in the previous video, I have already explained what are two-dimensional arrays. Okay, so two-dimensional array, you will have the two indexes. Okay, here you can see, right? A of 0, 0 is this value. A of 1, 0 is this value. A of 2, 0 is this 2 value. We also saw like there are two ways to represent two-dimensional arrays, row major order and column major order. Okay, now we will see what is row major order, what is column major order. Okay, first thing is row major order. So in an array of order m cross n, you already know what is m and n. Okay, m is number of rows and n is number of columns. Rows is like this horizontal, column means vertical lines like this. So in a row major order of array, okay, the first row elements are stored in sequential memory locations. So rows will be major in this type of method. So the elements which we input, it will be stored in this method. Okay, first row elements are stored in sequential memory locations, and then second row elements, and then third row elements if they are okay, the third row like that. And also, how do we obtain an address of particular element, a particular address of any element of the type A of ij. Okay, location of A of ij is equal to, if this is the address base of A, see we have, okay, this we have address of this, okay, base of A. Then how do we find the address of, see, A of 1 and 2 is this minus 3 address, memory address, and A of 2 and 1 is this particular portion. How do we find the address? We have address of this particular item, A of 0, 0. Okay, so location of A of ij, it can be A of 0, 1, A of 1, 2, whatever. Base A, I showed already what is base A. W is the words per memory location, word length we can call. LB is the lower bound, UB is the upper bound. Okay, so LB, it will be like 0, 1, 2, right? This is LB 0, upper bound is 2. Okay, as of now, LB is okay. So W into N. N is number of columns. Okay, in a row major order, in a row major order, you have to take number of columns multiplied by whatever this I minus LB plus J minus LB, where W is the number of words per memory location. So this is an example. Okay, 3 cross 3 matrix is there. Here in a row major order, initially, so it has to be stored in a like the way of rows, right? So initially this is stored in contiguous memory location 2 minus 2 and 3. Then this 1 0 3, this will be stored. Afterwards this will be stored. So row after the row. Okay, so this is the base address 2001 to A of 0 0, then A of 0 1, A of 0 2, then A of second row, A of 1 0, A of 1 1, A of 1 2. Next, third row. This is the third row, right? A of 2 0, A of 2 1. Okay, A of 2 2. Okay, this is A of 2 2. Understood? If you have any doubts, write in the comment section. Next, let's move on to column major order. Very easy. Here, what happens in a m cross n order of an array, in column major order, all first column elements are stored in sequential memory. So here in row major order, they will be stored in the rows. Here they are stored in the column in a sequential memory location. So first column initially, then second column, like that. So similarly, how to find the address of any element A of ij? This is the same formula, little bit change. I will tell what is the change. Location of A of ij is equal to base A. This is right. If you want, you can put a bracket over here, big bracket, one more, plus word length is same. Here you are not going to put n over here. Okay, n is number of n we use in row major. So in column major, we use m, that is number of rows we use in the next one. If it was row major order, we would have used n into I minus lb. Okay, that is the only change. Okay, so see here. So how do we store here? Okay, in a column major order. So column major order, we are going to store in a sequential memory locations via columns. Okay, so first we will store a of 0 0, then a of 1 0, a of 2 0. You can see here a of 2 0, 2 1 2. Okay, here there is a little bit change. Okay, next we'll be storing a of 0 1. Okay, a of 0 1. This you need to change in your textbook, this one, a of 0 1. Next, second, this is the first column, this is the second column, this is the third column. We are going to store in this way. First column is finished. Now second column, a of 1 1 is 0. This is a of 1 1. This will be a of 2 2 is 2. This is a of 0 2. You can see third column, a of 0 2. This particular element 3 is a of 0 2. This is a of 0 2. Then a of 1 2, a of 2 2. See, a of 2 2 is this particular thing. A of 2 2. Very easy, right? Okay, so we are going to store in the form of columns in column major order. In row major order, we are going to store in the form of rows. Very easy to understand. Okay, here there is a program to print elements in column major order. I'll also tell you how to print in row major order also. So as usual, we include these header files and we write our main function. Then this is a array of 5 cross 5. Or this is just initialization, or you are going to enter the order. What is the order? And you input that into the two variables, integer variables, row and column, or C. Okay, this is the index I and J. Enter the elements. You are going to enter the elements. Now this is very important. This is where you are going to store in the form of column major order. So now column major order. So for I is equal to 0, I less than C, I plus plus. For J is equal to 0, J less than R, J plus plus. J less than the number of rows, I less than the number of columns. Okay. So C in F, G, I. This is very important. You have to, in a column major order, A of Ji. A of Ji is very important. Don't exchange. Then your output will become row major order. Okay. You should be very careful over here. Now, the matrix in column major order, okay, you will put a end L, that is for the new line. Then you will print for I is equal to 0, I less than, here you are going to put R only. Okay, so here it will be changed. Then J is C. Okay, this is 0, 1, 0, 2, 0, 3. Then like that it will go on. So here they have given an example. Enter the order. Okay, 2, 3. Enter the elements. So if you want, I can give a different example. Okay, so here I'll explain. Say enter the order. We give 3 cross 4. Then you will enter some elements. Okay, enter the elements. Now how we are going to store like a column major order. For I is equal to 0, I less than C. C is 4. This is C, this is R. C is 4. Okay, you write over here 4. In a pencil you can write in your textbook, or in a rough notebook you can write. R is 3, right here. Okay, for I is equal to 0, yes, I is less than 4, I plus plus. For J is equal to 0, J less than 3, J plus plus. See in A of J, what is J? J is 0 here. Okay, I will write here. A of 0, J, and what is I? A of I is also 0. Then the first element which you are inputting will be stored here. Say some 2 you will enter. Okay. Then the next AFGI. A of I remains 0 only, right? Okay. Will be rounding over here. Then sorry, J remains 0. I will increment. It will become 0, 1, sorry, 0, 1, 1, 1, it will become 1. Then what are the next element? Okay, so like this, then a of 0, then 2, and then that particular whatever that element. So say you have order 2, 4, 6. This is a column. So here 2, 4, 6. Because it has to be 3 rows, right? So 3 times this will be executed. So see, column wise we are putting. So 3 cross 4 means here one column, here one more column, here one more column, here one column. These many has to come. But 3 rows. Okay. This is how we are going to store. So next time this will change. This will become A of 1 and 0, whatever the next element. So A of 1, 1, A of 1, 2. So next it is going to change again. Here this is A of ji. Okay, this is j value. J value is less than 3. So it will become till 3. It will be so this is 0 over, then 1, then 2. Okay, like that it will go on storing. So you can use, similarly you can use this example and write down in a pencil in your rough notebook, or with pencil you can just write it down and you will be able to understand. So here this is for finding a address. This we already saw, right? So this is a order they have given, MN, LB, everything is there. W is also been given. You just base A also they have given. Okay, so you have to find in a row major order. How do you find location of 12 comma 3? So it will be here 12, say, okay, in a row, 12th row and third column in a row major order, in a column major order also. So how do we find? So this is the way you have to find, and you already know the these formulas which we already discussed. This is very easy. Now we'll see what are the application of arrays. This can be asked for some 2 marks. Okay, advantages, disadvantages, and application. Application is very simple. Okay, this we use to implement data structures such as heaps, hash, queues, stacks, strings, etc. For strings and all we use more, for tables also. Then for mathematical vectors and matrices, you can just remember matrices, you know, right? What are matrices? Then one dimensional array we use in databases for records. Then advantages of arrays. Okay, these are advantages. They used to represent multiple data items of the same type. Okay, same type, by using a single name. Then it can be used to implement data structures like linked list tags. So we can write these kind of data structures using arrays. Okay, these are the types. Then two-dimensional arrays for matrices. Matrices you already saw, right? One-dimensional matrix, two-dimensional. And disadvantages. Disadvantages is the first thing, they have a limitation. How many number of elements that we have to know. That is the first disadvantages. And static in structure. Okay, because it's fixed size, right? We cannot simply we cannot increase. That will throw an error. Then since array is fixed size, this is just because of that fixed size. If we allocate more memory, then space will be wasted. It will be of no use. So if we allocate less memory, then we will create a problem. The program might crash, or many problems may come. How we are going to handle that problem? Okay, that we should know. Then the elements of array are stored in consecutive memory locations. So insertion and deletion are very difficult and time consuming because it's consecutive one after the other. You have to go, like, you have to change this, and then you have to like, because they are one after the other, it will be difficult for addition and deletion. Okay, these are the arrays. So we are finishing arrays here. In the next video, we'll be seeing stacks. This is also very easy concept. Okay, yeah. And if you have any doubts, write to me in the comment section. Thank you.